Let's go deeper into the mathematics of artificial intelligence by looking at how AI decides which words matter. Okay, so our objectives here include to understand why AI needs attention, explain the concept of self-attention, compute attention scores manually, build a simple self-attention mechanism in Python, visualize attention weights, explain how self-attention enables reasoning, and understand how attention improves context awareness. I mean, we've dealt with things about attention and context and all of this. But here we go a little bit deeper into the whole idea of self-attention. So, and we also want to relate self-attention to modern large language models or LLMs. Now, what's the fundamental problem here? Consider the sentence, the cat sat on the mat because it was comfortable. Now, we see it here, because it was comfortable. Is it the cat that was comfortable or the mat that was comfortable? So what does it actually refer to? Is it the cat? Is it the mat? So humans immediately understand that it refers to the mat because the adjective comfortable naturally describes the mat. Older neural networks processed words one after another and gradually forgot information from earlier parts of a sentence. So as sentences became longer, this problem became even worse. I mean, in a previous video, we had seen how there's a window, there's a context window, and once the context window is saturated, earlier words are pushed out. So, and that can lead to losing the idea of the overall context when words become so many. So transformers solved this challenge using the mechanism called self-attention, allowing every word to directly examine every other word before deciding its meaning. Okay, so then the big idea here is that instead of processing words strictly from left to right, that is, for instance, here, instead of starting from which other words are important for understanding me, if this is what we're going to process, so instead of processing just from left to right, every word then asks which other words are important for understanding me. So imagine a classroom. Every student asks, which classmate should I listen to before answering this question? So some classmates are more helpful than others for sure. So maybe some are more resourceful than others, but you need to listen to all of them to know who is who. So similarly, everyone decides which other words deserve the most attention. So you then pay attention to the people, the most resourceful people, the most informed people in class. So this idea is called self-attention, and this is we have seen this a couple of times in previous videos. So talking about what self-attention is, for every sentence, for every word in a sentence, rather, AI computes how much attention it should pay to every other word. So the final representation of each word becomes a weighted combination of information gathered from the entire sentence. And mathematically, we use the attention equation, which we have seen a lot of times already. So attention is a function of the query matrix, as you can see here, the key matrix, as you have here, the value matrix, as you have, and that is computed as softmax of the attention the I'm trying to remember the meaning of this division now. This is a dot product, right? And it is scaled. Yeah, I think this it is scaled now. So this attention score is scaled to make sure that there's stability, and then this softmax converts it into a probability, and then it is multiplied by the value matrix. So this sub k then is the dimension of the key vectors. So the softmax function converts raw similarity scores into probabilities that sum to one. I mean, we've dealt with that a lot of times. So now, why do we need three different vectors? Each word is transformed into three different vectors. Now, suppose the word is apple, it becomes the query, what information am I looking for? Then the key, what information do I contain? And value, what information should I share, depending on what is being looked for and what is available to share. So these three vectors allow every word to search for relevant information through the sentence. So always a query, what we are looking for, a key, what is available, and the value, what should be shared out of what is available as it relates to the original query. So then let's talk about step by step self-attention. Consider the sentence, the cat chased the mouse. Suppose we focus on the word mouse. So the word mouse asks, which previous words help define my meaning? So we have mouse right here. So the possible attention distribution is then like this. You have the with 0.02, cat 0.42, chased 0.48. Of course, chased describes the action that was carried out on the mouse, and that's why the probability is the highest. And cat carried out the action. That is why the next probability to the highest is cat. It belongs to cat. So you have D again, 0.03, and mouse 0.05. Now, notice that the largest attention weights are assigned to cat and chased because this was provide the most useful context for understanding mouse. There's a chasing and there's something doing the chasing. So those are like the most important. Now let's talk about computing attention scores now. Suppose the query matrix is this column vector 1, 2, and the key vector is this matrix, this 3 by 2 matrix. So if you first compute the dot products, we have KQ transpose. KQ transpose means that you have this matrix, this 3 by 2 matrix. Okay, KQ. So this is 2 by this is a 2 by 1 matrix, and then this is a 3 by 2 matrix. So we have to make sure that they agree. And I think the best thing we can do here is to have this is 3 by 2, this is 1 by 2. So we can actually make this into by transposing this, it becomes a 2 by 3. So this is 2 by 1 actually. So we multiply this together and we end up getting 2, 3, 4. Get 2, 3, 4 here. So because I mean 2, 0 and 1, 2, that is 2 times 1, 2 plus 0, that's 2. Then 1, 1, 1 times 1, 2 times 1, that's 3. Then 0 times 1, 0, 2 times 2, 4. That's how we get this right here. So we can then next divide by square root of 2. Square root of 2 here, of course, since d sub k, that's talking about the dimension. So we're talking about the query is two-dimensional. So we have square root of 2, which is 1.414. So we divide each of 2, 3, and 4 by that. That's the scaling part of it. Therefore, we say qk transpose all over square root of 2. That's 1.414, 2.12, 2.83. So this is 2 over root 2, this is 3 over root 2, this is 4 over root 2. And then applying the softmax function actually then gives us 0.14, 0.29, and 0.57. And that means you have e raised power this, e raised power 1.414, e raised power 2.12, e raised power 2.83. And then you now take e raised power 1.414 all over the sum of all the exponents. So applying the softmax function then gives us 0.14, 0.29, and 0.57. So that tells us that the third word, therefore, receives the highest attention. So that's the third word in the key, receives the highest attention. So for going to example one, I consider the sentence, Mary thanked John because he helped her, right? Of course, the question is, who does he refer to? Of course, we know he refers to a male, not a female. So we can decipher as humans that he refers to John. But what if it was James thanked John because he helped him, right? So of course that is a bit more not direct than what we have now, but we can still figure out that because uh because John he refers to John and him will refer to James in that case. So possible attention weights here now talks about we have Mary 0.10, thanked 0.05, John 0.6 because he refers to John, and helped 0.25. So since the highest attention weight is assigned to John, the model predicts John, he to be John, which is the correct interpretation in this case. And then we have an example 2. So consider the sentence. The trophy doesn't fit into the suitcase because it is too large. Is it the trophy that is too large or the suitcase? Now, possible attention weights are for trophy, we have 0.72, suitcase 0.15, fit 0.08, because 0.05. And we are looking at the it. What does it refer to? Is it the trophy that is too large or the suitcase that is too large? So from these probabilities now, we see that it is the trophy that is too large. So it refers to trophy because the trophy is the object that is too large. So this illustrates how self-attention enables logical reasoning. So we can then do everything we've done so far. We can then put that to test here. So imagine we have the query 1, 2 like we had before, and we have the key 2011, 1202, and we have the values 10, 0, 0, 1, 0, 10, 5, 5. So, and then we compute the attention scores, which is Q multiplied by K transpose, which we did before already. And that was how we got all these square roots, all the 1.414 and the rest. And then we do the weights, and then we try to, so we have the weights, right? And then we calculate the sums like that. So, and that gives us, so we have the attention scores and we translate that into the attention weights. And of course, as you're going to see, as you see, attention scores are all these ones like we saw before. And then we get the attention weights, that's the probabilities. And then the attention outputs now has 4.28 and 5.719. So it means that the so the second uh token gets the biggest attention right here. And then for self-attention visualization, if we have like the cat, D and cat and mouse like that, and we have the weights. Of course, we have weights already here. So the weights are the exponents of the scores like that. Okay, and the final weights are actually the weight over the weight sum like that. So at the end of the day, by the time we put all of this together, we see that mouse carries the biggest, has the biggest weight like that. So the tallest bar represents the word receiving the greatest attention, which is the mouse here. So this simple visualization helps us understand how the model distributes its focus across different words. And that's putting the first code here and this together. So in this case now we see the cat and the mouse, the cat and mouse as the words, and mouse has the highest weight. So let's talk about the attention matrix. So for a sentence containing four words, self-attention produces a 4 by 4 attention matrix. So an example is shown below. Now, the idea of self-attention is that every word thinks of how much attention it should give to itself and every other word. And as a result of that, if you have four words, we are going to have a 4 by 4 attention matrix. So an example is shown below. The cat sat and mat, and then the cat sat and mat. So D and D, that's 30%, D and cat 0.25, D and sat 0.20, D and mat. So the connection between D and mat 0.25. So so here we see that D and D has the biggest attention. So it has D on itself, right? Then when we go to cat now, so you see cat and cat has the highest attention here, and then sat and sat has the highest attention. So every word has the highest attention to itself. So the focus then now shifts to which other word does he have the highest connection with. So apart from itself, D is connected to cat and mat a lot. Then cat is connected mostly to sat, instead of apart from itself. Then sat is connected to uh, cat, apart from sat itself. Then mat is most connected to cat like that. So each row shows how much one word attends to every other word in the sentence. And that's a self-attention. Every word attends to itself and every other word. So let's see now. If you visualize the attention matrix, we have this. Yeah, you import number as NP, so import mat plus V as dot py plus as PLT, and you have the words D, cat, sat, and mat. And then you have this attention matrix just like we had up there. And then we want to plot the figure, we want to do a heat map to see how the words are attend to themselves, how they are connected, how they are related, like that. And then we have this heat map. So of course you don't want to bother about this this one's a word on itself. We don't care so much about that. But then we look at the based on this now, the darker the better, like that. So from here now we can see that apart from D, apart from itself, D is next related to mat. And then when we come to cat, apart from cat, it is next related to sat. Then when we come to sat, sat is next related to cat, of course, just like we have here. Then mat is best related to both sat and mat. In fact, more of D than sat, like that. So we see that the darker the set, the greater the attention assigned by one word to another. So attention heat maps are widely used by researchers to interpret transformer models. So we see how words are connected in a particular sentence or text. Then, of course, we've talked a lot about multi-head attention, and then we're talking about it once again here. Modern transformer models do not use just one attention mechanism. Instead, they compute several attention patterns simultaneously. So each attention head specializes in learning a different type of relationship. For example, head one can learn subject and verb relationships, and head two can learn object relationships. Head three can capture positional information. Head four can focus on semantic similarity. And head five can track pronoun references, while head six captures long range dependencies. So the output from all attention heads are combined to produce a richer representation of every single word. And then we come to talk about applications now. So applications of self-attention, basically. So reasoning is one application of self-attention. Reasoning requires connecting information across a sentence or even across multiple paragraphs like that. For example, Alice gave Bob the keys because he had forgotten his, right? So this model assigns strong attention from the pronoun he to Bob. He refers to Bob, allowing it to correctly identify the intended person. So this capability is fundamental to question answering, mathematical reasoning, programming assistance, and logical problem solving. And then apart from reasoning, context awareness is another thing. I mean, which is clearly connected to reasoning. So many words have multiple meanings. Consider the word, I mean, this is an example I've always used. He sat on the bank of the river versus she deposited money. She deposited money in the bank. So self-attention allows the model to examine surrounding words such as river, money, and deposited to determine the correct meaning automatically. Because bank can be bank river and river bank, and bank can be bank where you do financial transactions. So let's talk about advantages of self-attention. So self-attention captures long-range relationships between words because every word is related to itself and every other word in a sentence. Then it processes all words simultaneously rather than sequentially. Then it improves contextual understanding, enables logical reasoning, and supports parallel computation during training, and forms the foundation of modern large language models. So those are advantages of self-attention. And then we come to the limitations now. Although self-attention is powerful, right? It has limitations. One limitation is computational complexity. So computational complexity grows approximately at order n squared with sentence length. But if you have four words, the computational complexity is of order 16. If you have 16 words, that's 256. Imagine you have 1,000 words. That is 1 million. The complexity is of order 1 million and so on and so forth. So long documents require significant memory, and then very large attention matrices become computationally expensive. So if you have a 1 million, if you have a text with 1 million tokens, in that case, now you're going to have 1 million by 1 million. That's a lot. That's that's 10 raised power 6, right? So you square that, that's 10 raised power 12 or so. So attention weights alone do not always fully explain model decisions. In summary, we then see that self-attention is the core mechanism that allows modern AI systems to determine which words matter most in a sentence. So the question, this video is about how AI decides which words to choose, right? To decide the right words or whatever. How AI decide which words to choose. Is that it? Yeah, which words matter, yeah, that's the deal. So how AI decide which words matter. So AI decides which words matter through the process of self-attention by relating every word with every other word so that we know the kind of attention every word deserves from every other word in a text, in a paragraph, or whatever we might be doing. All right, so we come now to the practice problems. And from here you can see questions 1 to 12 clearly. In this place, I'll be solving problems 9 and 12. 9 says, compute the scaled attention score if the dot product between a query and a key is 18 and DK is 9. So that's a pretty easy one. Then number 12 says a sentence contains 15 words. What is the size of its self-attention matrix? Of course, I mean, it goes without saying that that is 15 by 15. So I'll just do that, and just keep it moving. So you have seen up to 12 there. Then from here, you can now see the rest. So yeah, so let's go on and deal with these questions as we get going. So let's start with we start with problem 9. Problem 9. 9 says to compute the scaled the scaled attention score, the scaled attention score if the dot product between a query and a key is 18 and D sub k is equal to 9. So that's pretty easy. So I just go for the solution. So we know that the scaled attention score is computed using this formula that the scaled score is dot product. That's the Q K transpose. That's the dot product all over square root of the dimension D K sub K. So in that case, then we say that the scaled score is equal to dot product, which is 18, all over square root of 9. So that is 18 all over 3, which is 6. So the scaled attention score is simply 6 here. We can just say, therefore, the attention score, or rather the scaled attention score, the scaled attention score is 6. Okay, so let's go on to the next one. Let's talk about that's problem 12 now. Problem 12. Problem 12 says a sentence contains 15 words. I mean, this is pretty much for like natural language processing. The sentence contains 15 words. What is the size? What is the size? What is the size of its self-attention matrix? So like I said, self-attention means every word is related to itself and every other word. So what is the size of its self-attention matrix? So to deal with this, so the solution here is like this. So if in self-attention, every word compares itself with every other word in the sentence, that's the whole idea of self-attention. So if a sentence contains n words, so if a sentence contains n words, then the attention matrix has size n by n. So with n equals 15, the attention matrix dimension, the attention matrix dimensions are 15 by 15. So the total number of attention scores, total number of attention scores is 15 times 15, which is equal to 225. So in essence, we say that the self-attention matrix has dimensions 15 by 15 and contains 225 individual attention scores, where each row represents, okay, let me just make that final statement and bring that to a close. Therefore, the self-attention matrix, the self-attention matrix for a 15 word for a 15-word sentence, has dimensions, 15 by 15, and contains 225 individual 225 individual attention scores, because it is going to be every word 1, 2, 3, 4, 5, 6, 7, up to 15, 1, 2, like that. So we're going to have 15 by 15 like that. So, and contains 225 individual attention scores, where each row represents where each row represents how where each row represents how one word distributes distributes its attention across all 15 words all 15 words in a sentence. All 15 words in the okay all 15 words all 15 words in the sentence. So that's how that goes. All right, so with this, we come to the end of this interesting video about how AI determines the words that matters. So how AI decide which word matters. So, okay, you can again look at questions 1 to, okay, here you can see questions 1 to 12 clearly. Of course, 11 is asking, explain why every row of annotation matrix sums to 1, because every row forms a probability distribution of the attention of every word on every other word. Then you have the rest of the questions right here. Let me know how helpful this is for you. If there's something else you'd like me to try out, feel very free to let me know. If you have subscribed to this channel already, I thank you very much for doing that. But if you haven't subscribed, it is a good time to subscribe. Why not go ahead and do that right away? Um, you can also hit on the notification bell so you can always get alerted each time a new video is released. Having done that, you can become a member of the channel also by clicking on join. That gives you some special privileges, which you'll find out as you click on join. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing math right. Bye.